Welcome. My name is Whitney Lee. I'm a CNCF ambassador, and I'm here with Abdel. Abdel, will you introduce yourself, please?
Hello, everyone. I'm Abdel. I'm a CNCF ambassador as well, developer advocate at Google, and I co-host the Kubernetes podcast.
So Abdel and I just had a long conversation about service mesh as it relates to observability. If you want to watch the full conversation, we made this board together during that time. If you want to watch the full conversation, there's a link to it in the description of this video. But if you're here now, you're going to hear a recap of everything we went over during our hour-plus long conversation. So Abdel, let's level set about what is service mesh. When we say service mesh, what do we mean?
Basically, it's a component that you install on your infrastructure to add intelligence to your network layer. That's the TLDR of what a service mesh is.
So if we want to go over this diagram, what did we talk about? Service A and Service B.
Yeah, so you see there we have two pods, which are Service A, two pods on the bottom, which are Service B. Kubernetes traditional non-service mesh implementation, you create Service B, which is the rectangle in the bottom. That gives you an IP address, it gives you a DNS entry, and it gives you a load balancer. So if the caller is A, then A would call Service B through its IP address, and that will resolve to one of the pods behind it. And that service also gives you an IP address, which acts as a load balancer. So that's traditional non-service mesh communication. If you add a service mesh, you inject these little squares that we have inside each pod, which are your sidecars. This is in the sidecar implementation. And those act as a client-side load balancer kind of thing, where the Kubernetes service is still used for service discovery, but the actual communication is sidecar to sidecar. Each of those sidecars have a full in-memory routing table of the IP addresses of all the other sidecars. And so as your application is trying to make a call to another application, it will be intercepted by the sidecar, and the sidecar will do security, traffic control, all the stuff that service mesh does, and then spit out the traffic to the other side. And then it will be received by sidecar on the other side, do the things it needs to do, and route traffic to the destination.
Sidecars enable pods to talk directly to one another instead of going through Kubernetes services. And the reason to do that is that you could add security features, you could add more advanced network routing, and you can add observability. Is that a good recap?
Correct. That's a very good recap, yes.
So it's that observability component that I'm extra curious about, because I've been doing a series about observability tooling, and I was surprised that none of the observability tooling are talking about service mesh, because when I talk to service mesh projects, they're all quick to mention that they can be valuable for observability. So we started this conversation by kind of going over what kind of observability information is being collected by service mesh. So I want to go over each signal, but first I want just more of a general answer. Like what observability information is being collected by service mesh?
Basically, most of the observability data is network layer observability. So it's observability coming from the network because of that sidecar implementation, or even without sidecar, which we can talk about. But most of it is gonna be non-application specific observability data, let's put it this way.
That's a great way to generalize it, but it really helps my mental model in general to have concrete examples. So we went through some of those. So, and for metrics, for example, what are some metrics that are being collected by the service mesh layer or can be collected?
Yeah, you have things like request count, request size, HTTP responses, the headers, how many bytes are sent and received, response times, latencies, whether MTLS is enabled or not. But you won't be able to get applications like CPU utilization, memory utilization, etc.
Or like any application behavior level
Correct.
information. And then trace-wise, what are some concrete examples about what you get and don't get?
So for tracing, you will be able to trace requests as it's going through the microservices environment, through the pods from one pod to another. And with Istio specifically, you will be able to even trace the request as it comes from outside, from a user or an application or an API call, going through the Istio ingress gateway and then going through all the components in your microservice. And with that, you get like the average time it takes each microservice to basically process that request. So standard tracing as it relates to a microservice distributed environment, I guess.
And then what you don't get is like whatever's once it's actually in the application, the request, whatever is happening within the application is not something that the service mesh can see. With that, you would need to implement your application or instrument your application with observability tooling specifically. And then we talked about logs. You said service mesh gives access logs. What does that mean?
Yeah, the most basic version of logs is what a service mesh gives you. And access logs is essentially this component talks to this component on this time. That's the timestamp. This is the HTTP request, get, put, whatever. This is the path, and this was the response code, and maybe port information, IP address information, stuff like that. So very, very basic logs information.
So then the question is, if I already have service mesh, and now maybe I implemented service mesh because I wanted MTLS. And then I was like, oh, well, I can use it for observability. Let's enable all these observability features. When I've done that, do I still also want to add dedicated observability tooling to my cluster? Or do I have it covered?
You might want to look at what the service mesh gives you in terms of observability and then make the decision based on what's in it and what's missing. I would say most of the time people will want more and will have to implement something more specific if they need more kind of application level detailed observability information.
So if you're looking for system level observability, service mesh might be enough for you. But if you want application level observability, you might want to add observability dedicated solutions. Okay, so let's move forward as though we're gonna use service mesh for observability in our system. We do that, we implement it, we've collected all this information. Now what? How do we visualize it? How do we query it? How do we make alerts from our service mesh observability data?
The good thing with most service mesh implementation is that they just use industry standards for generating the metrics, the traces, and the logs, which means you will need to install extra components to be able to collect and visualize those. So if we're talking about metrics, Prometheus, or plus Grafana, if we're talking about logs, any logging solution, Logstash, Fluentbit, FluentD, whatever. If we're looking at traces, then you might need something like Zipkin or Yager to be able to visualize the traces. I think the conversation that we were having is it doesn't stop at just service mesh installed, move on. It starts there, and then you will have to install extra things to be able to utilize the data.
To actually use it, which makes, it's par for the course in terms of managing a system. I think the last thing that we talked about that we should probably recap here is we're talking about all of this through the lens of a sidecar model. How does it change when there are other kinds of service mesh now? We have Cilium that does eBPF at the kernel level. We have Istio ambient mesh. How does this all change with the other types of service mesh?
It doesn't change that much in the sense that you will still be able to get the same observability data. The thing I think that a lot of people have to keep in mind is even sidecarless implementation still have a component that sits between your pods. So there is still latency is going to be there. Probably some resource consumption is going to be there. What changed really is where is the data generated and where it's coming from. But as far as you are concerned in terms of the observability information, you're still going to get the same metrics, the same logs, the same everything, same traces.
For the final question, will you explain Istio ambient mesh?
Sure. So Ambient Mesh is a new architecture in Istio, which is the sidecarless implementation or the sidecarless model, as you mentioned. And it's essentially splits the things that the sidecar used to do into two different proxies. One is called zTunnel, which is a node level proxy running as a daemon set that does layer 7 things like MTLS, some very basic authorizations. And then if you need layer 7...
I think you said this is layer 4.
Layer 4, sorry. Yeah, zTunnel is layer 4. Then if you need something at layer 7, like high-level authorization policies using service accounts and stuff like that, there is something called the waypoint proxy, which is an envoy proxy running on the namespace shared between all the pods in the namespace. So there are still proxies, they're not sidecars. One is at the node level shared between the nodes, the pods on the node, and one at the namespace level shared between the pods in the namespace.
You taught me that the benefits of this, there are a couple. One is that it's better resource utilization, because you're running less software as opposed to a sidecar with every single pod that you're running. But also it separates concerns between what's happening at L4 and what's happening at L7, because depending on why you're adding service mesh, you might not need both. So if you only are looking for one side of those things, you only need to install what you need. Is that a good, excellent. Is there anything else you'd like to add from our conversation today?
I think that if there is anything that people take from this recap is when you have a sidecar, you have something in between pods. There will be latency and there will be resource consumed somewhere. You also said before, it's a trade-off. You have to look at what am I going to get in terms of benefits and what am I willing to pay in terms of latency, resource consumption, cloud bills, etc.
I think if we're going to end it on that note, we should probably say a little bit more about what we get for benefits.
You get MTLS that you don't have to implement yourself. You get fine-grained security controls and traffic controls. You get some security features, authorizations, etc. Then you get observability, which is what we've been talking about.
If someone watched this video and they have questions, where would be a good place to ask those questions?
Just find me on Twitter or on LinkedIn and DM me, I guess, your questions. Or we are hanging out on some of the Slack channels for the CNCF. You can also find us there.
Thank you so much. Thanks everyone for watching. Goodbye.
Thank you.